Good morning, students. We were discussing about group theory. We have already seen the concept of symmetry in chemistry, symmetry operations and symmetry element, and proper axis of rotation. Symmetry is meant that a certain portion or a part of an object looks exactly like another part. For example, best example, Taj Mahal you can take. Otherwise, you take, we are saying Namaste. So when you take both the piece, you can see that if you cut the line through this, both the hands look similar. Or Taj Mahal, if you are drawing a line middle, you can see both the sides are identical. They are the mirror images. Or even this sculpture, if you take, you can see that both the sides, if you can draw exactly a line through the middle where you can cut both the parts equally, so that the patterns are repeated. So that is what is symmetry. And concept of symmetry in chemistry, when you take for a molecule's geometry and electronic structure are very important for predicting the chemical and physical properties. So we can use the symmetry to predict a molecule and its geometry. Thereby we can say the property, or that mathematical concept of using symmetry to explain or describe the molecule is what is known as group theory. So we use this group theory for predicting the geometry of the molecule, and if once geometry is known, we can able to understand the chemical and physical properties of the molecule. Then group theory is the mathematical study of symmetry, and that theory gives symmetry of electronic orbital, nuclear vibrations. It helps us to predict whether a vibration is IR active or Raman active, to correlate the orbitals of a reactant or product in photochemical or thermal reaction, so that we can study the stereochemistry of the one. So when you take the case of study of symmetry, we can have two parts or two things. One, we call it a symmetry element. Symmetry element is a geometrical entity to generate an identical structure. Geometrical entity means it can be a point or a line or a plane. So we use a geometrical entity so that the molecule can be changed and we can make it to come in the identical structure. The movement or the motion or the process what we do using this geometrical entity to get the indistinguishable structure is what is known as symmetry operation. And symmetry element and symmetry operation are interrelated. For example, if you say identity, doing nothing on the compound. Proper axis of rotation means we have a line through which we are going to rotate the molecule by an angle theta, which is equal to 2 pi by n. Then plane of symmetry means we are going to cut the molecule or reflect the molecule through a plane so that we get an indistinguishable structure or identical structure. Then improper axis of rotation means we are going to do two processes. Either we will reflect first and then we rotate through an axis perpendicular to the plane of reflection. Otherwise vice versa also you can do. Then center of symmetry. Whenever you take a molecule, if you are able to draw a line from the midpoint of the molecule, so in such a way that it meets identical atom at same distance at both the opposite sides, then we call it as it has a center of symmetry. And center of symmetry, the process what we do is inversion. So identity, doing nothing, plane of rotation, proper axis of rotation. Rotation is a symmetry operation. Plane of symmetry, reflection is the operation. Improper axis of rotation means reflection and rotation or rotation and reflection. And inversion is the operation used in the case of center of symmetry. Then proper axis of rotation is in a molecule is said to possess a proper axis of rotation, which we denote by Cn. If rotation about an axis by an angle theta gives a molecule a configuration indistinguishable from the original one. That is what, if we have a molecule, we are using a line to rotate it in such a way that when we get an identical structure, we call it as proper axis of rotation. For example, water molecule if you take, if you are drawing a line passing through the oxygen atom, midpoint of the oxygen atom, and rotating it through 180 degree, we'll get an indistinguishable structure from what we expect. Similarly, once more if you do, we will get the identical one. The second one is what is known as identity, that is doing nothing. We'll get the same type, but first by rotating we get only identical structure, they are not same. Then we used to denote it by Cn, where C represents circular rotation, n is the order of the symmetry, and theta is equal to 2 pi by n. Now, plane of symmetry. We are going to see plane of symmetry. What is plane of symmetry is? Plane of symmetry is actually the symmetry element, and the operation what we do is reflection. What is reflection? When you see your face in a mirror, your face will be seen as such in the mirror. So that is what is reflected. It is reflected. Your face is reflected on the mirror and you can see it on the mirror. Okay. So that process is what is reflection. So here what we do is we use a plane so that the plane will be reflecting the molecule. Plane which divides the molecule into two equal halves such that one half is exactly the mirror image of the other is plane of symmetry, and it is denoted by sigma. So the operation done is reflection. Example, boron trifluoride we take. Okay, so boron trifluoride if you take means you can say that this is boron trifluoride. Okay, can you see? I think you can see it. This is boron trifluoride. This is boron 1, 2, 3. 3 fluoride atoms is there. And what is the advantage of this is these all are in the same plane. Trigonal pyramid. Sorry. It's all the 4 atoms are on the same plane. Trigonal geometry it has. Okay. So when you take this, you can say that it has 2 plane of symmetry. What is first plane of symmetry is we can cut like this through the center. உங்கள் நினைச்சு பார்க்க ஒரு ஆப்பிள் எடுத்து you are cutting it. ஆப்பிள் கட் பண்ணும்போது என்ன ஆகும்? This is an apple எങ്കിൽ இந்த மிடிலூടെ we are cutting it. So ആ ആറ്റത്തിൻ്റെ in between ആയിട്ട് you will be cutting. So this is one plane. Okay. Then another one is you have here boron fluorine. What you can do is that you can cut a plate like this. On the fluorine middle, boron middle alone you are doing it. Appo what happened? You will get 2 identical structure. Then 3 is possible. Okay. This is first fluorine. If you keep it like this and divide by this plane, you will get another one and again the third one. So these are 2 planes of symmetry. One is cutting the using a plane we are cutting all the atoms. The plane will go in such a way that through the middle of the atoms. Okay. So what you will get? You will get an exactly similar structure. There is second one is there where it will be through a fluorine and a boron. Okay. So that is the second one. Okay. So this is the one. One is on the same plane. I have drawn like this way. So this if you take the boron, how it can rotate, or a proper axis of rotation if you take. Proper axis of rotation in the case of boron is like this. Idu madiri than it is. Okay. This is the rotation. Okay. This you take this pen as the line of rotation. Idu ippidi tilt பண்ணும்போது what happened? 120 degree tilt பண்ணும்போது you will get an identical structure. Again adine rotate பண்ணும்போது it will get a similar structure. So what will be the one is it is 360 divided by 120. So it will be C3 axis. So idukku perpendicular right you are getting a plane. See, this is the plane. Okay, this is the plane. You are getting the plane. This is the bond axis. So that is one plane of symmetry. Next plane of symmetry is in such a way that through one fluorine and boron. இப்படி வரும். Okay, அந்த டயக்ராத்தில் பார்த்தாலே you can see this is the one, இது bond axis. So இதுக்கு வந்து this is the plane. Okay, இனி வந்து இது வந்து ஒரு boron ஒரு fluorine. One is represented by violet, one is represented by green, and one is represented by red. So this is the three planes. So that plane will be in such a way. Okay, ഇതിലൂടെ it will go next இப்படி போகும், next இப்படி போகும். So these are the three planes in the case of. So you have one plane which is perpendicular to the C3 axis and three planes which are parallel to the 3C axis. So altogether 4 planes of symmetry boron trifluoride have. Then you will take water molecule. Water molecule, if you take, you have two vertical planes of symmetry. One is a thin plane cutting the atoms into two halves. This is what, and I have shown in the diagram. You can see atom and you take it as an apple, and the apple cut பண்ணும்போது what happened, ஒரு plane form ஆகுது. அதே மாதிரி what it will happen is இதுக்கு இந்த ஆக்சிஜனும் ஹைட்ரஜனும் மிடிலூட பாஸ் பண்ணன மாதிரி இப்படி. Okay, so what happened, the molecule, it will be reflected in the similar way. This is what is shown here. That is one. Any second எப்படி வரும், there is a plane like this, oxygen மிடிலூட going. So oxygen மிடிலூட இப்படி கட் பண்ணியாலே you will have a plane. Okay, this will be the plane. So what happened, you will get two identical structures. That is only shown here. Okay, this is the one what is shown. So is a plane cutting oxygen atom in between two high oxygen hydrogen bond. இப்படி வந்து it will be bending. Okay, so that is second plane in the case of water molecule. Now you have, so this is what is given. இது வந்து C2 rotation, oxygen வந்து 180 degree rotate பண்ணும்போது தான் what happened, I showed you what is the one. இது இப்படி இருக்கும், when it is rotated through 90 degree இப்படி வரும், இப்படி வந்தால் தான் it will become same இல்லையா, நம்ம வந்து பார்த்தது. Okay, இனி ஒரு plane வந்து cutting this one, so that is the same, all oxygenum hydrogenum on the same plane வரும், மிடிலோட ஆப்பிள் கட் பண்ணுற மாதிரி. இனி another one சொல்லுனது oxygen மட்டும் கட் பண்ணி இப்படி போகும். So these are the two planes. Okay, இனி next one is ammonia molecule. Ammonia molecule and BF3 molecule, what is the difference? If you take, இதில் வந்து you see these all are in the same plane. If you keep it on this paper, you can see 1, 2, 3, 4 all are touching the paper. Okay, but what is the difference of ammonia? Nitrogen is not on the plane, nitrogen is projecting up, only hydrogen atom. So this is not a planar molecule, that is a planar molecule. Okay, so if you take the case of this one, what are the planes you can have? It is, there are three planes is there. That is how we can cut it is, if you cut like this, imagine if you cut இந்த மாதிரி ஆக்சிஜனோட கட், sorry, நைட்ரஜனோட கட் பண்ணியால you won't get an identical structure. Okay, but if you cut it in this way, you will get an identical structure. That is, ഒരു നൈട്രജനും ഒരു ഹൈഡ്രജൻ്റെ മിഡിലൂടെ the plane should go. അതേമാതിരി ഒരു നൈട്രജൻ്റെ ഒരു ഹൈഡ്രജൻ്റെ മിഡിലൂടെ another plane. This is another, இப்படி கட் பண்ணணும். If you cut in this way, what happened, you have only one hydrogen here, these two here. So அது வந்து it will not look as an identical structure. Okay, so what you have to do is, if you want to get the identical structure, இப்படி ஒரு plane போகும். இனி ஒரு nitrogen and hydrogen இந்த மாதிரி, ஒரு hydrogen and nitrogen இந்த மாதிரி. So இந்த மாதிரி போன plane தான் what we call it as this one. Okay, இனி இதில் வந்து you can see this is explained.
If we now look at the ammonia molecule, we now see that there is a threefold axis of rotation going through the nitrogen, and a rotation of 120 degrees just moves each hydrogen into the next position so that the molecule effectively looks identical. So that was 120 degree rotation. Moving it again gives us
this
the
rotation
second
we have already seen.
20 degree rotation, so that the molecule looks. The third 120 degree rotation takes us back to the beginning, and again the molecule looks identical. In this case, we also have vertical mirror planes, and you can see that there is a vertical mirror there which reflects this hydrogen into this one. The central nitrogen and the other hydrogen line the plane and remain unchanged. Similarly, there's a mirror here, and that reflects this hydrogen into this one, the other two remaining unchanged, and a third mirror plane.
So that is ammonia's one. Then plane of symmetry, when we are taking from all the discussions, what we can see here is there are three types of planes in a molecule. One, we can say that sigma h stands for horizontal. If the plane is perpendicular to the principal axis, this rotation we use principal axis. What was principal axis? Principal axis it is the axis which is having maximum number of n value. But there are C2, C3 axis or molecule C3 is the principal axis. So and the principal axis in a perpendicular item. Suppose this is the principal axis and you have a plane which is perpendicular. In the madri or plane it is known as horizontal or sigma h. Okay. If it is parallel, we call it as sigma v, that is vertical. Okay, that is different one. It is dihedral. Okay, it is dihedral angle bicep panni vernathu. Okay, don't confuse it. That you will study in the higher class. You just remember sigma d is also there. Sigma where d stands for dihedral. You can say in this way, C2 axis on if a vertical plane bisects C2 axis, bisect panna madri irunale, it is what is known as sigma d. So you just remember plane of symmetry is of three types: sigma h, sigma v and sigma d, where h stands for horizontal, v stands for vertical and d is for dihedral. If you take the case of water molecule, you can take the example again, the water molecule. Okay, water molecule the principal axis it is this one. Okay, so this red is the molecular plane. So you have a plane like this. So what was sigma v, sigma h? Sigma h is if plane is perpendicular to the principal axis. This plane this was one plane and this was another plane. Ippidi oru plane illa perpendicular aayittu. What was this is ippidi oru plane irukku, ippidi oru plane irukku. So perpendicular means it should be like this. Ippidi it doesn't have a plane. Okay, so what was the one? It doesn't have a perpendicular plane. So sigma h, sigma horizontal is absent, but it has two vertical planes. This is one plane. Hydrogen atom, oxygen atom cut panni, apple cut panna madri it is coming. Second one, oxygen atom mattum cut panna. Idu rendum it is parallel to the axis of rotation. So water molecule two sigma v irukku, no sigma h irukku. So plane of symmetry means it is actually what is plane? It's a plane which divides a molecule into two equal halves such that one half is exactly the mirror image of the other. That is what is plane of symmetry. And it is of three types. One is sigma v, means sigma h, and one is sigma d. We are going to explain only about sigma v and sigma d. the principal axis in perpendicular ആയിട്ട് വരുന്ന സിഗ്മ എച്ചും vertical ആയിട്ട് വരുന്നത് parallel ആയിട്ട് വരുന്ന we call it as sigma v. So water molecule എടുത്താൽ you can see that it has only, this is the principal axis. So in the plane it is parallel, in the plane it is parallel. ഇപ്പിടി ഒരു plane വന്നിരുന്നേൽ it was perpendicular. So that is not the horizontal plane കിടയാത്. So only 2 sigma v is there. Okay, so that is only one. Thank you.